Welcome back to my channel, dear learners. So in this video we'll be talking about the supplement topics of unit 1.1, which is physical quantities and measurement techniques. In my previous video we talked about the core topics. You can go and check my previous video for these topics, and today in this video we'll be talking about the scalar quantities, examples of scalar quantities, vector quantities and their examples, and also we'll see how we can calculate graphically and by calculation the resultant of two vectors which are at right angles to each other. So we'll be talking about all these. So let's proceed and let's see what are scalar quantities first. So what are scalar quantities? The quantities which have only magnitude and no direction. They only have a magnitude. So what is magnitude mean? Magnitude means a value. They only have a specific value but no direction. What does it mean? Example, time. So if I have to say what is the time right now, let's say it is 11 o'clock. So you will simply say it's 11, right? You will not say it's towards east to west. It doesn't have a specific direction. That means time is a scalar quantity. So it has only and only magnitude and no specific direction. Similarly, if I say distance, so distance is also a scalar quantity. Why? Because I will simply say that the distance from my house to my home is 5 kilometers. From my house to my workplace is 5 kilometers. So it's I will not specify the direction. It's just the distance. It's 5 kilometers, right? So we'll be talking about more examples. Let's see another point. Every scalar quantity is one dimensional. Time is one dimensional. Distance is one dimension. It is in one dimension only. It cannot be 2D or 3D. It changes with the change in its magnitude. I am saying how will the time change? If I say it's 11 o'clock, it was earlier 11 o'clock and now it is 12. So if I'm changing its magnitude, time is changing because it has no direction, right? So how will a scalar quantity change? When its magnitude or its value changes, right? When its value changes. Last, it cannot be resolved as it has exactly the same value regardless of direction. Cannot be resolved. What does resolving means? So when we'll be talking about vector quantities, I'll let you know what do you mean by resolving. So resolving basically means that you can split it into components. But as scalar quantities do not have any direction, so how can you split them? You cannot split them that it is 11 o'clock and you can split into two directions, that this direction this is 10:30 and this direction. That is not possible, right? So these are the scalar quantities. They just have a magnitude. What are other examples? Speed is also a scalar quantity. Mass, I will simply say my mass is 50 kg, for example. I will not say I have 50 kgs of mass towards right. Right? Kidding. Okay. Then energy, and lastly temperature. These are some of the scalar quantities. Why are these scalar? Because they do not have any direction. They just have a value. I'll say what is the temperature of your room right now. Let's say it is 30 degrees Celsius. So it doesn't have any direction. It just has a magnitude. And what is the magnitude of this temperature? It is 30 degree. 30. What is the magnitude of mass in this case? It's 50. So this is the magnitude. The value is the magnitude. So scalar quantities are the quantities which has only and only magnitude but no specific direction. Some examples are time, distance, speed, mass, energy and temperature. Right? Moving on to vector quantities. Now vector quantities, they have magnitude as well as direction. They have magnitude as well as direction. Now example, I say there is a table. I have a table. Don't go on my drawing. Sorry for my bad drawing. Sorry for my bad drawing. Bad drawing. So I have a table and I have to apply a force on it. Let's say I'm applying a force of 10 Newton on it. So it has a direction that you can apply force towards the right, you can also apply towards the left, you can apply force from top, you can apply force from bottom, right? So you can apply force in any direction. So this 10 Newton, this 10 is the magnitude, right? And direction can be east, west, north, south, right, west, from top, from bottom, whatever you have to say, right? So force is a vector quantity. Second, vector quantity can be 1, 2 or 3 dimensional. Obviously, They can be in any direction. So they can be 2D, 3D or 1D. It changes with the change in its magnitude or direction or both. What does it mean? Let's say I have a force of 10 Newton. So when will this force change? Earlier I was applying it in this direction. I will say now I am applying in this direction. It is 10 Newton only, but now I am applying in opposite direction. So the value of force will change. Now you will say it is 10 but in opposite direction. So I can write minus. You can put plus or minus sign to show the direction of the vector quantities. Right? But I am saying it is in the same direction, this direction only, but this time instead of 10, I am applying 12 newtons. So the direction is same, but the magnitude has changed. Still, we will say that force has changed. Right? Still, we will say that force is changed. Why? Because the magnitude has changed. So either the magnitude changes or the direction changes. We will say that force is changed. Right? So it changes with either change in either of magnitude or direction. It can be resolved in any direction using the sine or cosine of the adjacent angle. We'll be talking about this in very much detail in your upcoming units. So basically, if I have a vector, so vector quantities are represented by an arrow at the head of them. So this is, let's say, this is how we represent a vector quantity, right? So this vector can be resolved into two components at right angles. One is this and one is this. Two components at right angles. So you don't have to go very much in detail. You'll be talking about in upcoming units. So what are the other examples of vector quantities? One is force. The other are, we have weight. So I'll say the weight of this particular object is, let's say, 20 newtons. Then it's always downwards because weight is a force due to gravity. We have velocity. Then we have acceleration. I know these terms are new for you people, but we'll be talking about these terms in the upcoming units. We have momentum. Momentum is mass into velocity. Again, we'll be talking in detail in the next unit. Then electric field strength. Electric field strength. And magnetic field strength. Sorry, magnetic you don't have to remember. One is gravitational field strength. Gravitational field strength means how strong is the gravity. It's always downward. It has a specific direction. It always acts downwards. Acceleration has a direction. We'll be talking about. Now you people will say, you are saying we'll study in next unit. Obviously we'll be studying in the next unit. So wait for a few days and I'll be uploading the videos for the unit 1.2 as well, subtopic 1.2. So just for a revision, what are vector quantities which have both magnitude as well as direction? They can be 1, 2D or 3D and they change with the change in magnitude or direction of both. They can be resolved in any direction. And some examples are forces, weight, velocity, acceleration, momentum, electric field strength and gravitational field strength. So what is the basic difference between scalar and vector quantities? The basic difference between scalar and vector quantities is scalar quantities has only magnitude, but vector quantities have magnitude as well as direction. Got it? Moving on to next. Now, how will we find the resultant of two vectors? Let's say I have two people, two boys. They applied force on a ball. I have a ball with me. Again, don't go on my drawing. I have a bad drawing. Okay, I have a ball with me and I asked a student to apply force on it. So one student apply force of say 3 Newton upwards and one student applied force towards the right, let's say 4 newtons. And I have to find the resultant force on this ball. Resultant means the net force. Resultant means the net force on this ball. So how will we find that using calculation? How will we find that using calculation? So we'll use head to tail method. What does head to tail means? Let's say, let's draw the first, let's draw the first vector which is 3 Newton. I have 3 Newton. Now this is the head from where you start the vector is the head and where you draw this arrow is the tail. Now take the second vector. This is the head, this is the tail. The head of one should be matching with the tail of another. So this is my second vector, which is 4 Newton. You can say the tail of the second is coinciding with the head of the first. Now what is the resultant? The resultant is the head of the first to the tail of the last one, which is this. This is my resultant R, pointing towards the end. So head of the first one to the tail of the second one is our resultant. Now if I am using the calculation thing, so how will I find this value of R? What will be my resultant force acting on this ball? So that means I have to join these two vectors. So I'll simply use my Pythagoras theorem. Mathematics here, Pythagoras theorem. So what does Pythagoras theorem means? That this hypotenuse, that means R, the square of this will be equal to the square of the base and the perpendicular. So let's call this as force A and force B. So I'll simply say R square is equals to A square plus B square. Or I can say R is equals to root A square plus B square. In this case, what is A? A is 3. So 3 square. What is B? B is 4 square, which gives me 16 plus 9, or I can say 9 plus 16, which is root 25, which is 5 Newton. That means this value of resultant is 5 Newtons. Right? So if I have to find the resultant of two vectors, now in your syllabus you just have forces and velocities. So you can find the resultant of forces and velocities in the same way. So if you have to use the calculation method, you can simply use this method, which is Pythagoras theorem. You just join the head of one to the tail of another, and the head of first vector to the tail of last vector is your resultant. Use the Pythagoras theorem and find out the value of your resultant. So in this case, the value of resultant is 5 Newtons. Right? Now if I am talking about the graphical method. Talking about the graphical method. Again, let's take an example. In this case, we'll take the forces again on the ball. Let's say I again have a ball, smaller ball this time. Again, I'm applying a force of, let's say in this case, I'm applying a force of 40 newtons. And I'm applying a force of 30 newtons, for example. And I have to find the resultant force acting on this ball, the actual force acting on this ball, or the net force acting on this ball, using graphical method. By calculation we can simply solve 30 square plus 40 square, and that's it. So but how will we find graphically? So for graphical method, what we will do, we will take a scale. We'll choose a scale. This time we don't have to use any calculation. We will choose a scale. Let's say, what does scale mean? Is on a scale you have centimeters. So let's say 1 centimeter is equals to, let's say, 10 Newton, for example. Right? 1 centimeter is 10 Newton. So if I have to draw 30 Newtons means 3 centimeters. This will be my 3 centimeters. And 40 Newton means 4 centimeters. Simple mathematics. If 1 centimeter is 10 Newtons, how will we draw 30 Newtons? It will be 3 centimeter and 4 centimeter respectively. So now again, let's draw. So you will take a scale, you will use a ruler. In this case, I'm not using a ruler. You will be using a ruler. And instead of 30 newtons, you don't have to draw a 30 centimeter line, because we have chosen a scale. So instead of 30 Newton, draw a line of 3 centimeters. So I will draw a line of 3. Okay, let's draw this vector first, then we'll join the head and tail. So let's draw a line of 4 centimeter. This is not 4 centimeter exactly, because I am not using a scale. 4 centimeter. Then take a scale, and again you will use the head and tail method. You will join the head of this to the tail of second. This is 3 centimeters. Right? And now what is the resultant? Resultant is this. So how will you find this? You will simply use a scale. You will simply take a scale and measure this length. Let's say this comes out to be 5 centimeter. For example, this comes out to be 5 centimeter. Now convert it. 5 centimeter, 10 Newton. 1 centimeter is 10 Newton, so 5 centimeter is 50 Newton, right? So the resultant is 50 Newton. So you have to use your ruler. You have to use your ruler for graphical method. Use a ruler. Okay, that's it. So just for quick revision, scalar quantities has only magnitude. Example, time, distance, speed, mass, energy and temperature. Vector quantities has both magnitude and direction. Force, weight, velocity, acceleration, momentum, gravitational field strength and electric field strength. Resultant of velocity or forces by calculation, use Pythagoras theorem. For graphical method, use your ruler, choose a scale, draw the lines, find the angle. You can also find the angle, this angle. You can also find this angle by using a protractor. By using your protractor, right? You simply have to measure this angle, at what angle this resultant force is acting. You will use a protractor and find this angle. So that's it for the video today. I hope you have understood. If you have any queries, do write me on yutika0050@gmail.com. And if you like the video, do share, subscribe the channel, and do let me know if you need videos on specific topics first, because I will be moving topic wise. So if you need any specific video first, I can record that for you people. All the best for your upcoming exams. Thank you.